Hi, my name's Brian Crawley. Thank you for visiting with me. I'm the construction team leader with the Federal Highway Administration in the Office of Infrastructure. I'm here to talk to you today about civil integrated management. Within this presentation, the objectives are that first I'll be covering where did civil integrated management come from? Second, I'll be covering what is CIM? How is it being used today? And third, finally I'll be covering where is CIM taking us for the future of construction? Where did CIM come from? Back in August 2009, Federal Highway Administrator Victor Mendez approached AASHTO, AGC, and ARTTA and asked them what could we do to accelerate construction of highway projects. So these groups with Federal Highway got together and looked at what's happening across the nation and proposed some ideas to Federal Highway Administration in 2010 on how we could accelerate construction of highway projects. The four proposals they came up with was first, create a utility relocation best practice list. Second, increase sharing of electronic data. Third, more consistent widespread use of innovation. Fourth, encourage teamwork with inspection and construction staff and personnel. This letter that was sent back to Victor Mendez from this committee was handed over to me, and I was asked to do something with it, make it happen, because we need to accelerate construction within the highway industry. So what I did is I took this letter and I went back to the original committee and asked them, what does all this mean? Please explain to me. Are we looking at technology advancements? Are we looking at policy change? What are we looking at here? What are we talking about? We actually formed a technical working group now to advance these ideas and to identify what can we do to actually change the highway construction industry today. As we brought together this working group, we looked at these different activities and some changes in technologies that we're seeing out there on highway construction, and we came up with the concept of civil integrated management. This is somewhat of a takeoff of BIM, Building Information Modeling, but engulfs a lot of the same concepts and ideologies. Within highway construction today, we're seeing a lot of different alternative contracting methods being utilized today to bring together more than just design build that we thought was innovative 10, 15 years ago. It's bringing together right-of-way activities, public relations, design activities, materials acceptance, surveying methodologies. It's bringing together a lot of different innovative methods that we're seeing in the delivery of highway construction projects today. Besides just alternative contracting, we also see advancements in surveying today. We're seeing laser surveying today that we're setting up on projects. It's running automatic machine guidance control systems. We are also seeing survey GPS dipsticks being used outside on projects today. We're seeing advancements in surveying and how it's more integrated into the construction project than we've ever seen in the past. Information modeling is taking a step forward also. We're seeing the use of 3, 4, 5, and some people are talking about 6D modeling of highway projects. Whether it's the complete project or just one specific detail on a project. We're seeing this advancement of information modeling. Now we step into utilities, where we're seeing 3D designs of utilities to assist in the construction process, as well as communication with utility industries of how we want and where we want to do our construction activities to mitigate and avoid their existing utilities, as well as we're exploring long-term storage of this data of as-builds so we know where the utilities are in 20, 30 years down the road when we know we're going to be out there again working in that same vicinity. We're seeing evolutions with real-time verification of quality and quantities of construction materials today also. These are coming in the form of intelligent construction technologies such as intelligent compaction, where we're looking at compaction methods on the fly and accepting materials with them. We're looking at homogeneity of temperature of our hot mix grades. We're looking at data acquisition with construction equipment and how can that be used for acceptance. We're looking at RFD technologies. There's a world of different technologies out there that all focus back into the center on completely managing our projects together, partnering as a whole, accepting this electronic data, building platforms in a data cloud, working in a virtual reality world and administering our projects. But it takes more than just technology to do this. It takes an earnest partnering effort in between our owners, our contractors, our design firms, our consulting firms that are managing the projects and doing quality assurance with our subcontractors, our material suppliers. It takes all of us working together and establishing these platforms and technologies that are assisting us in managing our projects today in an accelerated process that enhances safety and the environment. So where does SIM take us? This is a whole bunch of talk I've just went over with you, but where does this take us in reality? Let's look at a couple projects where we're seeing this technology and partnering between owners and contractors and consultants occurring today. First project example we have here is the Dallas-Fort Worth connector. It's a partnership in between TxDOT and Northgate Construction. What you see in the image here is a 3D modeling of quantities associated with this project. These different colors represent different materials, whether concrete, asphalt, base material, the primary materials components. And you're one click away from also getting the materials quantities necessary on these sections for your rebar, your lime treatment, your bond breaker, and other pipe and other miscellaneous materials. Once you take these projects to this 3D stage, quantity takeoffs and stagings, you're able to prioritize and scope out your materials, construction equipment, and means and methods to optimize your operation for cost effective. Once you produce this 3D model, you're able to optimize your materials, your quantities, your equipment, and operations to take advantage of the different stages of this 3D model. Now as we step into this next image, this is where we take the 3D model into a 4D element, where we incorporate scheduling into the materials, methods, and equipment. This is where you're really, as a contractor and an owner and consultant, able to scope out the project for just-in-time delivery of materials, equipment, and people on the project. This helps a lot with balancing your resources and utilizing their productive efforts to the maximum possibility. I would also add that within the RFQ of this project, it was not required to do this. The construction enterprise used this method to assist them in mitigating the costs associated with this project. It helped them win the project and do it in the most cost-effective means for the traveling public, which we're all trying to accomplish. One other piece of SIM technology that was used on this project was associated with tracking of their equipment and construction trucks. All the trucks and equipment had a tag associated with them that they were able to link and track and show where their equipment was on the project. This helps out significantly when you're paying your subcontractors for the loads delivered, as well as optimizing your maintenance frequencies with your haul trucks and your equipment. Knowing where it is, what it's doing, what it's hauling throughout the life of the project so you can optimize productivity. That's so critical to us today. Let's look at our second project today, the Western Wake Freeway, a partnership in between the North Carolina Turnpike Authority and Raleigh-Durham Road Builders. This first image here displays some of the technology they use to assist them in managing this sim-like project. This is an online project management system where the owner, the design consultant, and the contractor, subcontractors, and material suppliers were able to review plans as they were being developed and present conflicts back to the designers. You can see in the one diagram here where there's red outlines on the projects. This is where the contractor said, hey, we got a problem here, you missed a part. They're able to do this in real time to communicate that information back to the designer so the design can be finished and the contractor can continue building the project on schedule in real time in a data cloud environment. Data cloud environment meaning an online system where all parties could interact together and share their information, comments, and approvables as soon as possible. That's what the back screen presents, is the tracking of these different documents, where they are, who has them checked out of the online system, and where they are in the status of approval to advance to design. This is one example of an online project management system that's helping us today. Another example of a SIM technology that was used on the North Carolina project was the use of automatic machine guidance control systems. With the advancement of 3D modeling and automatic machine guidance control systems, we're able to tell our construction equipment the tolerances that we need to build a project. And with the operator and the output from the automatic machine guidance control systems, we can build projects today more productively. We don't have to repeat and go back and cut and fill our different quantities because we made a mistake or a hub moved or we didn't quite know where the material was going. The automatic machine guidance control systems help us. In the bottom left-hand corner, you'll see a picture of a laser surveying system that's set up on the project. It has a 360-degree laser in it. This here assists the automatic machine guidance control systems in maintaining their accuracy. For grading equipment that is using GPS that's located just above that slide, you can see the GPS receiver on the edge of the blade. With the on-ground laser systems and the use of GPS, this type of grading system can assure accuracy to 1/10 of a foot. This is outstanding for rough grading. Then on the left-hand side, you can see two pictures, one of placing down the hot mix asphalt base course. They're using this GPS and automatic machine guidance control system, and they're paving to millimeter accuracy on the project. On the bottom corner, you can see where the concrete paver is also running off this automatic machine guidance control system. No strings, similar to the asphalt, no strings out there. In addition, you can see an inspector there who's using a stick with a GPS receiver on top to measure the thickness of that concrete being placed. We're able to use these systems now to assure the quality of our products being constructed. We no longer now have to go out after 7 or 8 days and core this pavement to determine the thickness for the pay factor. We can measure the thickness on the fly out there, adjust the equipment on the fly, and produce more material within spec, and everybody is happier. However, the use of this automatic machine guidance control systems are not perfect. On this particular project, they actually had the concrete paver break. On a typical project, when the paver breaks and the mechanic comes out and they say, I got to order a part, it's going to take 2 weeks for the part to be delivered and install it, you're sending the crew home. And you're calling in the survey crew to set up a string line to do asphalt paving, because you might as well do asphalt paving while the concrete paver is being fixed. So in a week, the crew's coming back and doing asphalt paving. But with automatic guidance control systems and stringless paving, that's no longer a hassle. Actually, on this project, they were able to move some of their crew over to the asphalt paver and start doing asphalt paving immediately. Why? Because the system, once you set it up on the project, it's there for all operations to utilize. For the graders, for the pavers, for any piece of equipment that's running off this system. Now the question goes, well, what happens with your laser system or your GPS system? Let's say your survey system goes down. Well, it actually happened on this project. The lasers went out, the laser survey system. They had to call in the surveyors again to reset the laser survey. They had to call the surveyors in to reset the laser survey stations. But during this time where they couldn't pave, because paving requires this ground-based system to reach the millimeter accuracy, the graders were able to continue operating because the accuracy with the GPS systems and the satellites is good enough for rough grading. They don't have to have the ground-based laser system. Intelligent compaction is another important intelligent construction technology that's associated with civil integrated management. Basically, intelligent compaction takes the energy measurement produced by the piece of equipment and combines it with GPS location to give you a measurement of the firmness of the material that you're compacting. Really, it's like what this slide illustrates. On soft ground conditions or soft asphalt, it's hard to push. It takes more energy. On a firm ground condition, it's easy to push. That roller moves along. So there's different outputs associated with the engine. Utilizing this, you're able to get an estimation of the material's firmness. It's not a density. It's not a resilient modulus. So what you have to do when using intelligent compaction is first build a test strip and correlate this firmness measurement that intelligent compaction gives you with the respective material's density or density moisture measurement if it's base or subgrade, or its density if it's associated with your asphalt material. But what it shows you is really illustrated in these pictures. In the bottom left-hand side is a picture of the output that comes from the display screen above. Well, what intelligent compaction shows you is where the equipment has been rolling and that firmness measurement. In the bottom left-hand side of the screen is an image of one of the outputs. You can see in this particular area that based upon the correlation that they did on a 1,000-foot test section and then taking that into full-scale production, that the green area was adequately rolled. But you can see on the turnout areas at the front and at the back, well, the roller didn't necessarily hit all of the pavement area adequately. You can see the white strips. In addition, what you see in this image is that one white strip right in the middle. What caused that? What caused that on this particular section of road was the coal cow that was being used to pick up the windrow material and put it into the paver. The scraper on the back side of it was not adjusted low enough to scrape up all the material. So after it went through the paver and came out the back end and went through the rolling operation, adequate compaction did not occur in that center line strip. With intelligent compaction, the contractor as well as the inspector was able to see this immediately and adjust it respectively and produce the product that was in the contract and what the public expects out on the road. Real-time adjustment and feedback on the quality of the compactive effort of the pavement. That's what's great about intelligent compaction, is the real-time feedback. If we were looking at the traditional way of doing it today of coring 2 or 3 days after placing the pavement, we would be very lucky if that randomly placed core was hit in that center mark, as well as we'd be really lucky if we would be able to diagnose the problem prior to having a couple miles of this pavement down. But intelligent compaction allows that opportunity and allows us all to work together and assure we're producing the quality product we want. As I mentioned a little earlier, intelligent compaction is putting a display unit in the cab, having different slope sensors on the equipment, as well as accelerometers and engine monitoring equipment to measure the compactive effort that the other slides present here. Additional tools that are under developed to help advance these technologies and this partnering and civil and gated management is we're developing some 2-hour web-based training modules that will be hosted out on different sites. And these training modules will help us teach people construction practices about bridge slide-in technologies, intelligent compaction, stringless asphalt and concrete slip-form paving, and setting up survey controls for automatic machine guidance control systems. We're also going to be producing some technology briefs that will highlight specific technologies, as well as some separate ones that will produce some project-specific examples. So you can see a project, how it was used, why it was used, and the value it brought to the project for the public. And these will be focusing on 3, 4, 5T design and modeling of highway construction projects, automatic machine guidance control systems for earthwork, as well as for paving projects, as well as intelligent compaction. In summary, civil and gated management is all about intelligent construction and partnering, working together as contractors, consultants, owners, to produce the projects we need today. Thank you very much for your time. Feel free to contact me if you have any further questions or would like to learn more about these project examples or more information. Thank you.